Assalamualaikum warahmatullahi wabarakatuh. So we will continue with volume by this method. Okay, this one is for this method. Okay, where the cross section perpendicular to the y-axis. Okay, we let f be the continuous function on the interval c to d, and assume that R be the region that enclosed by x equal to fy, y-axis, and the lines y equal to c and y equal to d. Therefore, the volume of the solid of revolution that obtained by rotating the region about the y-axis is gonna be V volume integrate from c to d pi fy squared with respect to y. As you can see in this figure, let's say this is the figure for the example of the region that we are going to rotate, and this would be the image of it. Okay, that means when we rotate here at the y-axis, okay, we rotate here at the y-axis, this will be the volume then, the figure then. Okay, the same goes here. That means we drag from the axis of rotation, the line of rotation, to the farthest of the region bounded. This would be your R radius. As you can see here, this is your R. Okay, the distance between as you can see, the R is actually horizontal. Whenever your R is horizontal, by right, you know that you need to integrate with respect to y. Okay, when R is horizontal, that means we will integrate with respect to y, which means we will have a function here in terms of y. Okay, the R should be in terms of y, and so does here, it should be c and d should be the value of y. Okay, that means y1 to y2. Okay, as you can see, this is also an image of a circle. Okay, it goes, okay, there will be a lot of circles, okay, inside the figure until this is the largest one. Okay, maybe I didn't draw it correctly, but it's actually this part. Okay, let me try. Okay, so that means when we integrate, we actually find the summation of all the circles inside the figure. Okay, since the circle here, since it is a circle, that's why the area for a circle is actually pi r squared. We apply it here by finding pi fy squared. Okay, next, let's look at the example. The first one will be find the volume of the solid here obtained by rotating the region that bounded by the curve. This is the curve x equal to 9 minus y squared, and also the line x equal to 0, sorry, here, line x equal to 0, okay, about the y-axis. So that means it rotates here, okay. I think the question actually meant here is actually not x equal to 0, and another one is actually y equal to 0, because the graph is bounded here. Okay, next, since it is rotated at y-axis, that means this is the axis of rotation, right from the axis of rotation to the farthest away of the region bounded. As you can see here, this is your R, and your R is horizontal. By right, we know that V should be pi integrate with respect to y. Okay, this one should be from y1 to y2. Okay, so since we rotate here at the y-axis, therefore here we have the curve x equal to 9 minus y squared as our R. Okay, 9 minus y squared minus y-axis here is x equal to 0. So the distance between the radius should be right minus left. Okay, so the right is the function 9 minus y squared minus 0. That's why R is equal to 9 minus y squared. Okay, we need to integrate v equal to pi from 0 to 3, why 0 to 3? Because this is the lower limit of the region, and this is the upper limit. Okay, since at first you don't know the value here, what you need to do is find the value, right? So the value here can be found by finding the y-intercept. Y-intercept means x equal to 0. Okay, 9 minus y squared equal to 0. We will have y equal to plus minus 3. Okay, since this is at the positive part, so this should be plus 3. Okay, and then here we integrate from 0 to 3. 9 minus y squared, squared, remember, it need to be square. Okay, integrate with respect to y, expand, we will have 81 minus 18y squared plus y power of 4. Integrate this function, it will be 81y minus 6y cubed, y 6 because 18 divided by 3 is 6. Okay, plus y power of 5 over 5 from 0 to 3. Substitute the value of 3, okay, in the integral here, in the function here. Okay, and remember to write 0, even though it is 0, please write 0. Okay, and the answer should be this one, 129.65 unit cube. You can also write your answer in terms of rational function. Okay, next, based on this diagram, you need to determine, based on the diagram, determine the volume of the solid produced if the region R here is revolved about the y-axis. That means it will revolve here about the y-axis. Okay, since this is the axis of rotation, right from the axis of rotation to the farthest part of the region bounded, this is your R radius. R is horizontal. That means automatically the volume should be integrate with respect to y. Okay, here would be y1, this is y2. Okay, R is, this is the line, y, and this is the curve, y to x cubed. Since we want to integrate with respect to y, the function should be in terms of y. So, rewrite this function with x as the subject. You will have x equal to y root of 3, which can also be written as y power of 1 over 3. Okay, so the distance here, the radius here should be y power of 1 over 3 minus 0, because this is x equal to 0. Okay, and then here, since the value has been given 1, so that means we need to integrate from 0 to 1. V is equal to pi, integrate 0 to 1, y power of 1 over 3, power of 2 with respect to y. Here it will be y power of 2 over 3. Integrate y power of 2 over 3, it will be 5 power of 5 over 3 over 5 over 3, which can also be written as such. Okay, 3 over 5, 5 power of 5 over 3. Substitute the value of upper boundary minus the value of the lower boundary. And remember to still write 0 even though the value is 0. Okay, and thus the final answer is this one, 3 over 5 pi or 0.65 unit cube, or you can also multiply 0.6 with pi. Okay, that's all for this topic. Thank you.